we're going to do is we're going to start talking about elimination. Elimination is a different process that is more conducive to the problems that don't have a variable with a coefficient of 1. Of course, you can use elimination all the time. There's just times where substitution is more convenient, and times where elimination is really the best way. Okay, this example up here on the board right now, that just reeks of elimination. Simply because substitution would be kind of a pain. First, your x's have to be lined up, your y's have to be lined up, and your constants have to be lined up. I could give you one where everything's all out of whack. First thing you have to do is to get everything in whack. All right, and make sure everything's lined up correctly. Secondly, what you're looking for is you're looking for two coefficients that are vertically lined up. You want those two numbers to be the same or opposites. So these two right here or these two right here, we want them to be the same exact number or opposites, like 5, -5. If they're not, and you can see on this example that ours are not, we're going to have to cheat. Okay, we're going to have to change the equations so they fit what we want. And it's always your decision on what how you're going to change these equations to get it to work. Here's what I'm going to do on these. I'm going to multiply the top one by 3. And when I multiply by 3, the whole thing all the way across gets multiplied by 3. I get 15x plus 9y equals -3. I'm going to multiply the bottom one by 5. You can multiply by whatever you want as long as all three terms get multiplied by whatever you're multiplying by. If I multiply the bottom one by 5, I get -15x plus 10y equals 60. Why in the world did I do that? Because now I have vertical coefficients that are opposites of each other. So that's why I chose to do this, and that's the decision you're going to have to make every problem. What are you going to do to get this? A 15 and a -15. Okay, so that's your first decision you have to make in elimination. If you make a decision and it works out for you, then you have to either subtract them if they are exactly the same, or add them if they are opposites. Because what we want is we want these to become 0. And we're adding or subtracting straight down. So 15 and -15, for those to become 0, you add them. 15 plus -15 is 0. If I would subtract 15 and -15, that would be 30. I don't want that. I want 0. So I'm going to add these columns straight down. And when I add straight down, I get this. 0x plus 19y is 57. 0x is nothing, so I just have 19y equals 57, which means that y equals 3. The whole point of getting same coefficients or opposites was to combine those two equations so this goes away. So then we could solve for only one. So our answer to this question is something 3. Our solution to the system of equations. We don't have a bubble in elimination, so we have to go back to one of the original equations. So I'm going to put 3 right there. You can put it into the first one or the second one, whatever you want. And you just have to put 3 in for y and solve for x. And this is just Algebra 1 work. And I get -2. So my answer, -2, 3. Okay, 4x minus 3y equals -4. 3x minus 2y equals -4. Somebody in the previous hour brought up a good question here. They said, oh, look, we've got two the same, the -4s. That doesn't count. we're only looking at the coefficients of the variables when we're looking for same coefficients or opposites. So, in this case, you can either go for lining up the x's as sames or opposites, or lining up the y's. And I'm going to show you both, just to show you that it works. So if I'm going to get the x's to be the same or opposite, I'm going to multiply the equations by 3 on top and 4 on bottom, because that's going to get me 12s. And this, just like anything else, the more you practice these, the better you get at them. There are my equations after multiplying. The 12s are the same. And when they are the same, you subtract. When they are different, you add. Okay? So I'm going to subtract these two equations straight down. These are a little bit tricky because look at all the negatives. So you have to be a little careful. You have to take your time. The 12s go away. Negative 9 minus negative 8 is negative 1. And negative 12 minus negative 16 is 4. Negative y equals 4. I get y equals negative 4. Some students really enjoy this process. They get it. They love it. They wish we could do it all the time because it's the one thing they get really well. I mean, they just go right through these problems. In fact, some kids, instead of putting the negative 4 back in, will go back and do elimination again to figure out y that way, or to figure out x. They'll go back and multiply to get rid of the y's because they have more confidence in that than substituting the negative 4 back in. So I'm going to substitute the negative 4 back in and then solve for x. Get x equals negative 4.
So for that last step, you can put it in either one, right? You can put the negative 4 in 3. Okay.
Either one, because we're trying to find the coordinate that works in both. So that's if you were getting rid of the x's. If you looked at the original problem, is everybody done with that? You need that a little more? If you wanted to get rid of the y's, you would multiply by 2 and 3. Because that would get you minus 6's for your y's. You would subtract, and you get the same answer. See how it's working? You get the same answer.